And then the number of moles, if you want to find number of moles, it would be molarity times volume in liters. Sammy, are you answering the questions, or that's your question? You're trying to help, right? Answering the questions? Okay, great. Okay, good. Thank you. Thank you so much for that. Okay. For today's experiment, remember last week he said beside the nature of the alkyl halide and the solvent, there are other factors that can affect the rate of the reaction. Yes, it's the polarity of the solvent and temperature. And those two factors are studied in this experiment. So when we have a standard, that means 70% acetone water solution as the solvent, and room temperature. That's the standard. So if we change the polarity, that's like to 80% based on the procedure, where it tells you like now in the different trial, you're changing the procedure. I'm sorry, based on the procedure, you're changing the polarity, and you want to find out how much faster the reaction will take place at a more polar solution. You also change the temperature, and you study or you monitor the reaction or the color change at 3 different temperatures. Normally, by increasing temperature by 10 degrees, the rate is going to double. So we are trying to study that in practice and see what is happening. So we are going to, we're going to check the solvent, and we are going to check the temperature as well. Okay. For the reaction is Solvalis' reaction. The indication for the reaction to be done is the color change or appearance of a blue color. And that would be kind of endpoint of reaction. At that point, 10%, based on the design of the experiment, 10% of the reactant has changed to the product. So we know that is the 10%, or the design of the experiment is in a way that 10% of the total amount of the alkyl chloride has been reacted. So we can use that for our calculation also, with that assumption if needed for the calculation. So we already have that ratio. With that being said, you can use the equation if you simplify it. So it's all this work from equation number 4 going to 5, 6 to 7 is trying to simplify it for you. It's not always, equation 8 is not universal and is not always true, but based on the design of today's experiment, we make it in a way that we design it in a way that when the color change happens, that means 10% of the alkyl halide has reacted or has been solubilized. And a simplified equation to calculate the value for K is 0.104 divided by T. T value, that's the time. How long did it take? Then you can find the value for K. Now you can do that at 70%. So you're looking for the time. You can do the same calculation when the temperature is high, when the temperature is low. Then you could find the value for K at different temperature or at different polarity. Now, how would you interpret your data? That would be different. Yes, that is true. This is just the one condition. You can use the equation 4 as well. Yes, you can use it. But then you have to have a stronger math, which if you have it, more power to you. But the simplified version of it, based on the design of the experiment, it would be the use of equation 8. So we don't test you based on your knowledge of, the log and anti-log and all that. So we make sure that that's a simplified version of the equation 4. And equation 4 is, this is derived from equation 4, so the original one should work. And that's great that you got the same answers. That's perfect. So the only data that you are recording at this point is the time with different setting based on part A and part B of the experiment. So when you do the experiment, different trial, you want to find how long did it take, what's the trial number, and how long did it take for the color change, what was the temperature, and what's the value for K. The average K is like after if you have like 3 trials or 2 trials, you take the average K. The solvent composition at the standard at the beginning is a 70%, but when you use that in, I can tell you the effect of the solvent, then you are going to use 2 milliliter, since you're using the 2 milliliter of the solution in acetone, and then the rest is water, then it's going to be 80%. Okay, so it's going to change from 70% to 80% of water and 20% of acetone. So you're changing the composition, and you record that in the table. So basically, when you're collecting data, you can basically expand this portion, and then you make it, you fill in for different trials, and then different effect of temperature and effect of solvent. So I'm gonna have to go to the other page. Thank you. That's great. Thank you. Okay. So when you watch the video, you have to just pay attention, especially now the chat option is not there. Sometimes I write, but since the chat option is not there, you have to pay close attention to listen to the number and the seconds, that number of seconds that I say for each trial, and you write that down. When you are done recording this number, when you're recording the time, then you can go ahead and do your calculation and submit your report. So as part of the report, there is a graph, and the graph, this is the last part of the report actually. At 3 different temperature, when you are studying the temperature effect, at 3 different temperature, you are going to find the value for K. Basically, you find the T, and then you will say K equals 0.104 divided by that T. When you plot this against the 1 over time, I'm sorry, 1 over temperature, that's in Kelvin, then you can calculate the slope. Now, if you use a manual graph, manual calculation is going to be rise over run. And if you are using Excel for the calculation, then for your graph, then you can just use look for statistics, and you find the slope for the graph. When you find the slope for the graph, the slope of the graph equals this equation, or it equals this fraction here. Activation energy over 2.3 times value for R, which is the universal gas constant. And from this equation, we can find the activation energy. The greater the activation energy, the more significant will be the effect of temperature, because the activation energy is high, then it requires higher temperature or more energy for the reaction to happen. So for endothermic reactions, you would basically get a high value for activation energy, or the effect is going to be greater, so the slope is more steep, so you get like a higher number for slope. So the effect is more significant. Yes, the graph is just for the temperature portion. Yes, just for the temperature, the 3 temperature, and the K value for the 3 temperature. just one graph only. The other one, you could just you could just compare the time. How long does it take? Okay. The initial molarity, if you have dilution, you would use M1V1 equals M2V2, and then you are going to use the final volume as the total volume. Initial volume would be the volume of the component that you are looking for. So when you are diluting, you just have to use M1V1 equals M2V2 for the molarity. When the color change happens, 10% of that initial number of moles is reacted, so you can record that. If you get like a 1.1 mole, then 0.01 mole will have been reacted. Whatever you find the number of moles, which is the molarity times volume in liters. That would be number of moles. Then you would say that 10% of that would be reacted. When the color change, that would be 90% of the original. So whatever is the original, then that would be 90%. So if the original one, let's say the 0.1, then at the color change is going to be 0.09. So 10% less than the original one. Okay. If 650 seconds, what's the value for K? You just divide the number by the seconds. You find the value for K. For the percent water acetone, oh, I'm sorry. I think I answered some of one person at least. Maybe wrong, because this one refers to earlier question. It refers to question number 1. This is the composition. So it may not be 70% or 80%. You just have to see how many, what's the total volume and how many milliliter is for T-butanol. So we have 3 milliliter and we have 6 and 9, 3 divided by, so that would be like 1/3, right? 33%. 33%. Is that right? Yes. 33% acetone and 67% water. Very good. Okay. I'm going to just take a few minutes and talk about the final exam. Maybe I can stop the recording and record that separately, so I have a recording for the final exam. It's not going to be long, but let me stop the recording.